I'll start.
Okay, where did stuff go? Okay, that's you guys over here. I accept the recording. You guys can see my screen here?
Yes.
All right. Yeah, so I've been working a lot. I just realized I didn't post the new documentation to the website yet, so I was about to do that. But yeah, so I've updated the documentation. I'm going to show you after this meeting. I will upload it. But for now, I'm going to just, this is from my desktop here, the build I just did of the HTML to show you what the latest looks like. So yeah, if you go into plotting, you've got all your existing plots, the ones you can run automatically. But if you're looking to do new plots, you want to go into plotting.plotter. And yeah, and I finally got the documentation changed. So the order stays in the order it appears in the file instead of being alphabetical, because here we want our meta figure on top and then the general plotter and then the specific plotters underneath. But yeah, so essentially we have a few classes, creates objects for this. We wanted to have a meta figure because, a matplotlib figure by itself isn't necessarily all that useful. It doesn't have all the stuff all the data that was used to build it. It doesn't have all the methods you want to do on it. So having a meta figure that holds the figure, all its axes, all its data, all its information in one place is really useful. So yeah, the meta figure object. It's an object to hold a figure along with all the axes, the settings, and all the methods you can do on the figure. Right now, you have to enter a kind when you create a meta figure. It's used in file naming and during saving and stuff. Maybe give it a generic default, but for now, you have to put it in. And then, yeah, you want to describe your subplots. So the number of subplots in the figure. So you can either feed in an integer, and then it'll just be the number of rows of subplots. Or if it's a list, then it'll be the number of rows, the number of columns. The default is none, which just creates one axis that you can start building your figure on.
Sorry, Joe, what does the kind refer to? Is it just like a label for the...
I have a note here. I should probably rename kind to name. It's just the name of this particular meta figure of this figure collection. And then when you save it, it uses that as the start of the file name.
Perfect.
Yeah. And again, you might want to change that to name. Might make more sense than kind.
Label, maybe.
Label, yeah, exactly. And a few additions that I just put in because I wanted to have this ready to build complex figures. And to do that, you have to have subplots and you have to be able to share axes and twin axes and stuff. And so now, yeah, we have that capability to share X. And yeah, we'll build up a figure in just a few moments here, and then you'll see what this share X and share Y do. RC params. So this is a cool thing because by using this, you can get publication quality figures, directly with a single command. Every time you run it, you'll get that publication quality figure because you can adjust every single thing in the figure with matplotlib.rc params. So title size, axes, label sizes, everything is in this. So you can make a dictionary of whatever things you want changed and feed that into this RC params, and your figure will come out beautifully formatted. Auto size is a new feature, and what this does is when the size of fonts and everything is generally fine when you just got one axis, but it uses that same size as you add more axes, and so it's way too large. It's better to sort of decrease the size of that stuff, which decreases the white space. What this auto size does is it increases the size of the figure, the 8x10 or whatever the size of the figure is. For each additional subplot, it's going to make the figure size about 35% larger. And that seems to be about the right number to zoom out appropriately for each. You got a bunch of subplots, you want the text and stuff much smaller. So yeah, I've got it defaulted to 0.35 right now, but a better default might be to leave it off unless you know what it's doing. but I can show you the effects. And then, yeah, you can put fig size and dots per inch right away into here. And then, yeah, this has got a bunch of methods that you can call on it right away. You can save the figure, show the figure. Once you've deleted a figure, matplotlib can't reshow it. So I put this reshow figure in, which actually sort of transplants to a new figure to reshow it. Doesn't come up much except when you're building figures and you want to see it again and you've already deleted it. Add a super title, and then finish the fig. And again, so all this stuff is in the documentation here, the name of the file, the description of the file. Show fig doesn't have much. Add the super title, all the options you can feed into it. And then finish fig, what it does is it finalized everything. And then if you've got it set to save, it'll save it. If you've got it set to show, it'll show it. So this is something you want to run at the end of your figures just to finalize everything. Yeah, and so our general plotter is our, the base object we use for all our specific plotters. And this holds all the methods you use on an axis. A figure can have multiple axes. So any given figure might use several general plotters to do it. And yeah, so with an axis, you've got, you can twin it. You can, again, you can feed the RC params right into here. If you want to load data or save data that comes with the figure, format the axis, add the legend, add the scale bar. And again, at the end of any axis you make, you're going to want to finish axis, which does the final stuff you need to do. And this is all documented here. And then, yeah, we move into our specific plotters. So we've got a scatter plotter, a line plotter, all that stuff. So yeah, at this point, let's jump right into the demo. And I just made this while the meeting started. I just made a directory called demo, created my NetPyNE virtual environment in there, which spits out all this stuff. And now I am in, well, I went to doc to build the website. So yeah, now I'm in that demo dir. And I use a particular example to run all these things. The one that has the most different things in it, so it's good for testing and stuff, is this LFP recording example. So what I do is I'll run CP, copy recursively the NetPyNE examples LFP recording up here into a directory called LFP. And so here I am in my demo dir, and now I've got this LFP directory, which is an example from NetPyNE. Then I need to change directories into that cd LFP, and then run nrniv modl, compile the mod files. Great. And now this netlfp.py is what we're going to be running, but it automatically generates some figures that are kind of funky. So I'm going to block that out real quick. Yeah, just this simconfig.analysis plot LFP has some weird options. Save that. Yes. Okay. So then let's just execute that. I'm going to do it in ipython-i netlfp.py, and that will run it. Give it a second here. Okay, so completed successfully. So at this point, we can sim.plotting.plot tab. We've got all the existing plots that we can make. So let's go ahead and do, well, I don't know. Let's look at plot raster. It's very common. And then, yeah, we'll want to set show fig equal to true so we can see it. So plotting that plot raster. Okay, so this is, the default raster plot, got a fairly detailed stuff. Great. So yeah, you can run any of those plots with very few. You want to add show fig equals true if you want to see it. Save fig equals true if you want to save it, but all those should work without anything else being put in. Okay, so at this point, we're going to build up a more complex figure. And yeah, so to start, like I said, we're going to want to create the meta figure. That's our first step. So I'm going to say sim.plotting.meta figure. And again, we have to say what kind it is for the naming. And for this, I'm going to like throw raster and hist and stuff in. So I'm just going to give it a call it raster hist. Yeah, we're going to make a couple subplots on this one now. So we're going to have 2 rows and 1 column. And yeah, these are all going to be time on the x-axis. So well, no, I won't set that yet. Let's do it without the sharing, and then we'll see what it looks like. But yeah, so my fig. So now we should have this raster hit with here with 2 rows and 1 column. Let's go ahead and my fig dot ax is going to be the axes that are in your figure. You can see, yeah, we've got the 2 subplots. Let's go ahead and give those names, x1 and x2 equals, yeah, my fig.ax. And now, yeah, x1 is just a single axis, x2 is a single axis. Now we can plot into these individually. So on this top one, let's go ahead and plot the raster plot. Sim.plotting.plot raster. Now, normally when you don't put an axis into this, it creates a figure and an axis and then plots in it. But now we're going to plot into an axis that already exists. So we're going to say that this axis equals x1. And yeah, that's what we'll do for now. And again, so now let's do my fig.showFig. There we go. Great. So we've got our raster plot on the top here. Our second one isn't filled in yet. And, all the stuff that comes with this. So then let's, yeah, you don't have to plot in sub-axes. You can plot multiple things in the same axis. So let's go ahead and plot. This used to be a figure that we could generate automatically. So you might want to put this in when we're done, but we'll add the spike frequency on top of the raster here. So let's do sim.plotting.plot spike freak. And what is going on here? Okay, I don't want all the options yet. Okay. And yeah, we'll just say axis equals x1. And I send out plotting.plot spike, and it didn't show up. My fig.showFig, is that going to work? Nope. What about my fig.reshowFig? There we go. So yeah, you can see how the show fig, once you've got the figure already, it can't show any changes to it, but reshow now allows you to do that during development. And this is, there's a few problems here. This is real messy. We don't want to have all of them. Maybe just have the average. And also we can see that we overwrote, this should be cell IDs on the GID plot or on the raster plot. So it overwrote things, which is not something we want. So we're going to make a couple changes. And actually, I'm going to start making a little file here. Yeah, you can build this file into a figure eventually, but we're going to say, let's just copy from here. My fig equals all this. And then let's see here, we had and then we want x1 and x2 equals my fig.ax. And then, yeah, we want that sim.plotting.plot raster. oh, there we go, axis equals ax1. Copy and paste that into there. And then we did,
Joe, I'm not sure if you know the command history. And
yeah, I'm flipping. I mean, the up arrow, you mean?
No. Like if you type history, you see all the list of commands that you just run. And sometimes I use it to copy like you're doing now.
Oh, nice. I love learning new things. Oh, look at that. Oh, very cool. Okay. Yeah, so sim.plotting.plot spike freak we want to add as well. And yeah, okay, so this is our plot so far. So if we just, copy and paste all this, we should get a new figure. And at the end, the very end of our thing here, we can say myfig dot show fig. Anyway, okay, so let's see what it looks like now. Great, so that's the figure we just generated. We got back there. Now we're going to do some manipulations. We want to get, this is where we want to twin the x-axis, because we've got two plots on here with different y-axes. So let's go into our plot spike freak here, and we are going to want to say twin x equals true. Okay, so then let's see what that looks like real quick. Good. Okay. So that twin X, what you can see is now you've got the right cell GIDs for the raster plot here. And over here, hidden behind the legend, we've got the spiking frequency. It's also very messy. We're going to change this to just include all cells instead of all cells and each pop. Mm-hmm. And that will just show the average. So let's take a look at that. Nice. So we've got just the average spike frequency here. The legend on the side here we can see is blocking it. So let's turn this off on this plot, and we can actually have it on the plot below later. But to do that, we can just do plot raster legend equals false, and also on plot spike freak legend equals false. And yeah, we'll just run all this again. Great, so we got rid of the legends, and our plots are starting to look much better.
Nice.
Great, so then on the bottom one, let's do the spike histogram I did earlier. That seems to work pretty well. So now on this, we'll do sim.plotting.plot plot spike freak. No, we want plot spike hist. And for this one, we'll put it into axis 2. Yeah, and we'll just start with that. I keep trying to save it. I've got a habit of saving things frequently. So great, yeah, let's see what that looks like. Okay, so yeah, so now we've got our raster plot and our frequency on top, and we've got our histogram below. We're still going to want to do a bit of cleaning up here. The legend obviously runs way off. We don't necessarily need all that information. On that plot spike hist, there is a legend. You can either set it to, I'm going to set it to minimal, which will reduce the length of it. So when you put legend to minimal, legend equal, oh, excuse me, it's actually pop rates, not legend. And yeah, this is all in the documentation, should be good. Okay, there we go. Now our legend looks much nicer. It doesn't have all the additional information, but it still includes the overall spike frequency. Oh, our plot's starting to look pretty good here, except these titles are overlapping. Let's get rid of the titles. I don't think we need that. So in the plot raster, title equals false. In the spike freak, we'll go title equals false. And in the spike hist, we'll go title equals false. There. Okay, the title still showed up for some reason. Oh, I had title equals none before. Which that might be the problem, I guess. Title none. Somebody might want to take a note. Maybe we want to improve that. So title equals false also works. But title, oh, well, that didn't work either. This is working either. Working earlier. Okay, well, I don't know why I can't take the title off. I'll have to look into that later. But yeah, so we can also add a super title. myfig.add soup title, and you can see what's there. Add soup title. If you hit a question mark afterwards, you can see all the stuff. T is the text. So we'll do add soup title T equals my multi-axis figure. Paste all that in. Great, we got our super, oh, well, great. Well, now it took the titles off for some reason, which is what we were trying to do in the first place. So that's great. Looks a little different than it does when I did earlier, and I'm not entirely sure why. But yeah, so you can see you can build up sort of complex figures out of these subparts. Was there anything else I wanted to show with that bit? No, overlapping, multiple ones, showing and saving. Oh yeah, and then, okay, so at the very end of, instead of, if you're gonna turn this into a figure you're gonna use, then at the end you want myfig dot finish fig, and here you would say show fig equals true, save fig equals true, and yeah, that'll do the showing and the saving and all that. So yeah, let me just run this real quick and we'll look at what it looks like in the file. Okay, so generated it again. And here in LFP, we can see, yes, it's called netlfp underscore raster hist, which is the kind we gave it. And yeah, looks really nice. Oh, another thing you can do real quick if you're using the same x axes is you can do the share x, right? Twin x, and then where did I do share x? I don't have it on here anymore. But oh, when you first create the figure, if you share x, let's look at that. So I'm gonna just rename this real quick. No twin. And then we're going to run this again. But now up here, when we generate, when you have to say that you're going to share the axes when you make the figure. So you have to know in advance. We're going to say share x equals true up here when we generate the figure. And then, great. Yeah, we can see that when you share, it gets rid of, the time is going to be the same here. It gets rid of those. And then on this top axis, we can also, you have to do it manually, but we can say x label equals none. And copy that to the second one as well. X label equals none. Okay, run all that. And great, now we've gotten rid of, we just have the one time axis with the notations on the bottom. Nice clean figure, put this into a function And you can generate this for whatever data you want. Okay, then quickly, I was just going to show you another, the LFP plots, showing you can do it 2 by 2 as well. So yeah, let me just, I'm going to just copy this over all together and show it to you and then run it all at once rather than build it up. So yeah, what we've got here is, let's go to Python. There we go. So yeah, I'm going to make a meta figure again. I'm going to call it LFP multi. This time I'm going to make it 2 by 2. So it's going to be a total of 4 plots, 2 rows, 2 columns. And again, yeah, so we've got 4 LFP plots. I'm just going to plot one of those into each axis. I'm going to add a super title and then finish the fig, show it and save it. So let's just copy all this and paste it in. Great. So it's got a little tinkering to do, but you can see that you can get all the plots into, it's very easy to build up complex plots. One problem is going to be with this, with the spectrograms. It wants to generate one for each electrode. Obviously, we only have one plot. So for here, let's just go include equals, and I'm going to have to look at the documentation for spectrogram. Let's see here, plot, LFP spectrogram. And we've got, okay, oh, it's electrodes we want. Electrodes equals average and all. We just want electrodes to equal average. And that should help clean that up. Great, so now it's just that the single one with the single color bar, the average frequency spectrogram. Or here, we might want to take off this color bar label or shrink it a bit, and so on and so forth. I think we want to do, anyways. So yeah, you'll have to do a little tweaking around to get this to look perfect. But again, it's very easy to build up complex figures now by plotting into the axis.
That's great, Joe.
All right.
That's awesome.
Yeah. So yeah, I think that's all I had to show. If anybody has any questions or anything, obviously in the future as well, I'll be around. Anybody, any questions or comments now?
Joe, I have the finish figure thing. Is that only if you need to save? Because it seems like they still show up, no? Even before that or not?
Yeah, let me see. Finish fig. I actually want to look at the code. Let's go to plotting. Plotter. General plotter. Oh no, we want to finish fig. Meta figure. Finish fig. So what finish fig does is it looks for soup title in the quargs, tight layout in the quargs, and save and show in the quargs, and just runs those all at once. So for example, in the let's go into NetPyNE.plotting.plot raster, for example. Oh yeah, I want to see the code though. Source. So yeah, with plot raster, for example, the first thing you want to do is get the data. So I would create whatever you're analyzing, create a new function called get whatever data you want, and that prepares or prepare data, I guess. And then that gets your data exactly where you want it, and then you use that data into the scatter data dictionary for each one of the types of plot. If there's a dictionary, these are all the things that MATLAB accepts into that plot. And this way you can set it up right here. You go through the quargs, create the metafig and the scatter plotter stuff. And then, yeah, so what I do is, oh yeah, it's in, yeah, so to make it easier, it's part of the dot plot. It's part of the plot function. So that way you only have to call one thing when you're doing this. You don't have to call finish fig. All you have to do is call plot, because plot raster. And where's that plot? I'm just going to go to GitHub real quick. NetPyNE plotting plot raster.
I thought the finished fig was only for the meta figure or not?
Oh, yes. Excuse me. Okay. Plotting. Yes. Plotter. Okay. And then, yeah, in the plot scatter plotter, general plotter. Okay. Okay. Here we've got our scatter plotter. And yeah, so each plotter has a plot function inside it. And what it does is it creates the plot and then it calls finish axis. And then if it's a little trickier, but if there's only one axis on a figure, it'll also automatically call finish figure. So you shouldn't have to call these yourself with these built-in functions. When you make a new plot, whatever, you'll have to make sure that, you know, these things get called. But yeah, a lot of this is built in already.
Okay, great. And so for the new plotting functions in general, to format them, you recommend using these RC params, right?
For anything complicated. So for simple stuff, well, yeah, I mean, I guess even font sizes and stuff. Yeah, I would use RC params. Let me just show you. Yeah, import matplotlib. So if you import matplotlib and then execute matplotlib.rc params, you can see just the enormous list of stuff that you can set. So yeah, you can set animation. So axes, edge color, face color, whether you want a grid, what the label color is, what the line width is, whether it's got spines, the title properties. Yeah, so essentially anything you want to change on a figure, you can change with these RC params. So yeah, it's a nice way to do it. Just throw out the ones you want into a dictionary and feed that in to RC params when you're plotting.
Perfect. And last thing I wanted to ask, like for the functions that are like the analysis functions that are not yet ported over to this new plotting format, and for any new functions that we want to add in the future, are there any tips or hints that you would recommend of how to go about, like to make sure that they are using this new, you know, structure, the parent class and all this stuff? Like we want to add new function, where do we start? How do we do
okay,
it?
so yeah, if you so let's say you wanted to port plot traces over.
Okay.
What you're going to want to do is create in the analysis, you're going to want a function that's prepare traces. Okay, and that's going to take care of getting the traces you want, you know, ignoring the ones you don't want, and that'll take all that and it'll just output the trace data that you're actually going to plot. And then, yeah, so you're just going to start by creating a meta figure. You're going to have to figure out in advance how many axes you want. So the number of axes will be the number of traces. You know what I mean? You've got the trace data, so you know how many there are. So that you're going to set the number of axes and stuff. Get your meta figure set up. And then for each one of these, for each one of those axes, you're going to want to call the lines plotter. Let me open up plot raster here. Demo, NetPyNE. Plot raster.
Okay, so this meta figure, you can also use it internally, no? So not only by the user, but as a NetPyNE developer, you can create functions that make use of meta figure.
Yes, if you're making any new figures, I would use metafigure because it's got all those methods that are standardized. So you can save it, you can load it, you can do all this stuff automatically by using that metafigure. So yeah, when you use a metafigure, you can, you know, if you just one axis or however many axes you want, that gives you access to all the metafigure stuff, the saving it and all that. If you want, but then if you want access to all the axis formatting stuff, then you want to use one of the plotters. Okay, so for example, plot raster uses the scatter plotter. So let me just walk you through what plot raster does here real quick. If raster data is none, you're going to get that from prepare raster.
Mhm.
And then, yeah, you load the data, you pull, and then, yeah, you pull the information out of the dictionary that held the data, get the information you need in individual variables, sign it, spike times and spike ins. This is some stuff for formatting. Create a dictionary with a color for each population, a list link. So yeah, and then basically in scattered data, in scatter plotter, these are the inputs that it takes. Image plotter takes different inputs. Lines plotter takes different inputs. This is just what goes into the matplotlib scatter plotter.
Mhm.
And so you can assign all these things. And then, yeah, set your axis args and stuff. And then, yeah, raster plotter equals your plotter is the scatter plotter with that data you fed into it.
Mhm.
And then, yeah, so that creates the nice axis with all those axis options. You don't necessarily have to use the legend and the color bar and stuff I've got. You could do it on your own. That's fine. But I've created these. It makes it easier to do it automatically this way. You can use the built-in stuff, the legend parts and everything. Yeah, so basically the first thing you want to do is get your data into the form, that you're going to be plotting. And then you want to apply that to whatever your plotter needs.
Sure.
So let's look at the lines plotter here. So here's the general plotter and its methods. Add legend, add scale bar, add color bar, finish axis. Okay, so yeah, the scatter plotter is looking for this information. Let's look at the lines plotter, line plotter. So this is matplotlib. If you want to plot a line onto an axis, this is the information you need. Really, all you need is X and Y. And so this data.get, if it's not there, it feeds in a none. And so if you've got X in your input, it'll pull it out. If you don't have color, if you don't have marker, it just uses the matplotlib defaults. And then, yeah, plots it using that. This is not really all that useful. Matplotlib doesn't make it easy to plot multiple lines on one axis. So we've got what we call the lines plotter. So for example, the LFP signals are 4 lines on the same plot. And they use this lines plotter. And then it's an array of X and Y instead of a single one, it's several of them, a list or an array or whatever it is. And then, yeah, so it plots, this goes through and loops and puts all those lines on the same axis. Okay, so yeah, you would want to get your traces data into this data form and then feed it into lines plotter, and it'll plot them all on that axis.
Okay.
When somebody wants to start working on this, I'm happy to sit down in the beginning and work together.
Perfect.
Yeah.
Thanks so much. No, I think it's really useful. I was thinking maybe the next time we convert one, maybe with your help, we can write like a small guide of how to do it for people who want to contribute in the future.
Yeah.
And yeah, we can put it as an example. But yeah, this is great. Thank you so much, Joe.
Yeah, you're welcome. And again, I'm always around, so feel free to pester me for questions and bugs and whatever. And yeah.
Cool. Let's stop recording.